All right, in this section of our chapter on parallel and perpendicular lines, we're actually going to go back and do a little review of slopes of lines. Now, before we start that, though, I do want to do a warm-up with you. So go ahead and pause the video at this point and work out these problems where we're adding and subtracting fractions, really, in terms of the numerator and denominator. But go ahead and see what you can get, and I'll come back and I'll share answers with you. Okay, so for number 1, you should get 2/5. For number 2, negative 3/2. Number 3 is undefined, meaning you have a number on top but 0 on the bottom. And number 4, you should get an answer of 0. So go back, if you didn't get these answers, go back, check your work, and see if there's some mistakes that you can identify that you can change going forward. Okay, so our objective for today is to be able to find the slope of a line and then use slopes that we calculate to determine whether lines are parallel or whether they're perpendicular or maybe they're neither. So some vocabulary: rise, run, and slope. So quick reminder, rise is in the vertical direction. Run is in the horizontal direction. And we'll use those two concepts to help us with calculating slope. All right, so the slope of a line in a coordinate plane is a number that describes the steepness. Okay, and we use this in real life, whether it's to determine, what category a ski slope should be, whether it's a black or a blue. We can use it for different ramps where we can establish what a certain value means in terms of the steepness. And we'll do that by using points on the slope or on a line to determine what that slope or steepness amount is. Okay, here's a diagram that kind of goes through the definitions of those vocabulary words we had at the beginning. You'll notice here we have rise, we have run, and we have slope. But along with this section on slope, you can see here we have the formula for calculating it. Okay, now I'll tell you a couple places that students make mistakes. One is they get these flipped around, and they'll put the y coordinates on bottom and the x's on top. So something I use to help students remember is we'll say that the y's go up in the sky and the x's go down in Texas. Okay, and that sometimes helps us remember. The other mistake that we'll have is either we may add them instead of subtracting, or we may switch around the 1s and 2s on either the top or the bottom only. So what I want to tell you, though, is if you switch the 1s and 2s, right, as long as they correspond, right, if I have the 2s for the x and the y at the front and the 1s at the back, fine. If I switch it and I have y1 and x1 at the front and the 2s at the back, it will still work out. Okay, but that's kind of gives you an idea of some things I see where students will make mistakes, so that'll help you maybe pay attention to those. Here to the side in this diagram, you can see a little bit of an example and a drawing in terms of how we calculate that slope. So rise up, and then we'll run. And I always like to have students calculate the rise first. Okay, we'll go up or we'll go down, and then we'll move to the right. So let's just get started. Let's dive in and let's do some calculations on slope. So we're looking at this first line, A to B, right here. And in order to use my slope calculation or formula, I need to determine what these points are, what their coordinates. So you can see that my first one is at -2, 7, -2 to the left, and 7 up, kind of like the pop, -2, 7. And B would be at 3, 7. Now, once I have that information, then I'm good to go. There's one interim step you may want to do that I also teach, which is labeling these coordinates oops, let's label that as y1 and x1, whereas I might label this one as x2 and y2. And again, if you switch them around, you're going to be okay. So that kind of helps me figure out what goes in what place in my formula. So when I have that now, I can go in, substitute, and then simplify to where I get a value. Now, with this value of 0, to me it makes sense, right? I'm not going up, I'm not going down. It just has a 0 slope, a nothing. So it's flat in a horizontal line. So anytime you get a 0 slope, you're going to think of horizontal lines. Let's try another one. Let's try AC. So here's my line, A to C. I've got 2 points, and it could be any 2 points on a line that you can use to calculate the slope. Okay, but I would suggest picking points where the coordinate lines come together rather than picking something out here in space. Okay, because here you're going to have a fraction or decimal to do this, and that's going to make it a lot harder and less accurate. So for my 2 points, A again is negative 2, 7. This time, C is going to be 4, 2. And now I throw them into my formula, do the calculation, simplify, and I get a fraction in this case. Okay, negative 5/6. Makes sense again, right? Negative going down, right? I'm going down the slope as I read it from left to right. Okay, and we read our slopes as we move from left to right. So negative 5/6 does make sense. Okay, let's try the next line. In this case, it's going to be AD. So the coordinate for A is still the same. D now is negative 2, 1. And I'll put those in, do my calculation, and I notice something here where I'm going to get a result of 0. And if you remember, that meant it was undefined. And undefined slopes are vertical lines. Okay, up and down, right, in this direction. Horizontal or 0 slopes, I should put, that's not right, I need to put like that. Forgot my cross through there. Okay. So this is just a reminder, right? A fraction that has a 0 in the denominator, we can't do that. Now, as you get into higher and higher math classes, you may find that some of your teachers will tell you that it's a slope or a value of infinity. Okay, now that's beyond our class, but you may see that. Okay, one more line left. And this one's going to be CD, right? CD, right here. So for my first point, 4, 2, okay, that's going to be for C here, right? And it's fine, I can have them flipped around like that. So 4, 2. And for D, it's negative 2, 1. We'll put those into my formula, do the calculation, and I find that it's 1/6, which is a positive value. So my slope's going up from left to right, which again makes sense. This slope is positive, whereas a C would be negative. Again, as I'm reading them from left to right. Now I'm going to leave you with one to do on your own in this check it out section. So pause the video, go through your calculations, try and find your slope, and then I'll come back and we'll see how our answers look. Okay, here's your calculation and values and answer. Okay, you should get a slope of 2. If you did not, look back at your coordinates, check where you put them in at, and then check your calculation. Those are typically the most common mistakes that students will make. So just to summarize on slopes themselves. So a positive slope goes up from left to right. A negative slope is going to go down from left to right. A 0 slope is just a flat horizontal line. And an undefined slope will be a straight up and down vertical line. Okay, let's try an application. Now, sometime most of you are going to go off to college, and you may be driving from your house back to school. So this is an example of Justin doing that very thing. At 4, he's 260 miles from home, and at 7, he's 455 miles from home. So these look like key pieces of information. So I'm going to go ahead and underline them just in case I need to go back to my problem and find them. Okay, now what it's asking us to do is this section right here, graph the line, and find and interpret the slope, meaning what does the slope mean? So I'm going to put up a coordinate plane here for you with that line already drawn. And this may be on your notes already as well. You'll notice that my scale here is not the same as it is on my x-axis. Okay, but it is a good scale, right? We're going by 100s each tick mark. On the horizontal scale, we're going by 1s. So then I'll go ahead and plot my points, and then I want to put them in here so I see them, right? 4 and 260, 7 and 455. Okay. The other thing I would advise you doing is to label, right? Mine doesn't have it labeled, so I'm going to put that in here now. So we've got miles, and I'm going to put this as time. Okay. Maybe I should call this, maybe a better word for this would be distance rather than miles. Miles is the actual measurement, okay? Whereas I have hours here. The next step in this is going to be go ahead and calculating the slope. So I'll substitute my values, then do my calculation and simplify if I can, and I find this 65, okay? 65. Remember what I have here and here, right, in terms of units. So when I interpret this, or what does it mean? It means that Justin is traveling at an average rate of 65 miles per hour. Here's one for you to do on your own, very similar, but go ahead and pause the video, work it out, and I'll come back with an answer for you. Okay, so your answer for this, we've got Tony traveling, and, oops, sorry about that, Tony's traveling, and we want to know if he's traveling at an average speed of 60 miles per hour, okay? And by 6:30, he would have traveled 390 miles. Now you notice that that's not shown on our graph, right? 390 miles isn't represented, but I can do it with the calculation to find that. Okay, now on to this. Parallel and perpendicular lines. So we can go back and we can use our values of slopes to compare lines and determine if they're parallel or if they're perpendicular. So in a parallel line, right, they're only parallel if they have the same slope. So parallel if and only if they have the same slope. Whereas in a perpendicular line, okay, if I were in a perpendicular line, if the product, they are perpendicular if and only if the product of their slopes is -1. Product, multiplication, okay, multiplication answer we'll call it. So let's go in and use these two theorems. Okay, so we have one line that has a slope of a over b, and the slope of the perpendicular line is -b over a. So those two ratios, there's a special name for them, and we call them opposite reciprocals. Okay, reciprocal means we flipped them over. Opposite meaning this ratio is positive, this one is negative. Okay, opposite reciprocals. Little cautionary note here. Just because you have 4 points doesn't mean that you have two lines. They could be right on top of each other. So make sure you're graphing and drawing. So here's what we have. We have some information about some points. And what we want to know is we want to find their slopes so we can tell whether they're parallel, perpendicular, or neither. So the first thing I think we should do is go ahead and plot those points. Okay, Plot and label your points. Then we'll go ahead and draw the lines. So here's what you should have. You should have y, u on the vertical axis, x over here to the side, and v down here in quadrant 3. Now I can go in and calculate my slopes, right? So I know I want to calculate the slope for uv, so I'm going to use the points for u and v. So there's u, here's v, and again I would label them x, y. Maybe you'll make those x1, y1. Maybe we'll make this one, whoops, x2 and y2. That's kind of hard to see. I'll go back in and use my slope formula. So I have -1 minus 2 and -1 minus 0. If I do the calculation and simplify, I end up with the value of 3 for uv. Okay, so let's just write that just so we have it, 3. Now let's do the same for the xy line. So my calculation with my coordinates is 2 over 6, which gives me a -1/3. Now I want you to see something. Let's make this a fraction. And I notice, hey, you know what? These are opposite reciprocals of each other. So their products are -1, right? The product of the slope is -1, which tells me that the lines are perpendicular. Okay, so but you got to calculate the slopes before you can determine whether they're parallel, perpendicular, or neither. So let's try another one. A few different points here. You have your coordinates all given. Got a coordinate plane here on the side. And we'll try and get some graph paper in case you need graph paper to do some of these in terms of delta math. If you have your own, go ahead and bring it in. So let's plot our points and our lines. And now this actually helps me visualize what line am I drawing the slope for, or defining the slope for. Okay, so for GH, now I can recognize a little bit easier which coordinates I need. So I'll put those into my slope formula, do my calculation, and simplify, and I get a slope of 1. Now if I try that same thing for IJ, using their coordinates, get my calculation done and simplify, and I get -2. And what I find is, you know what, if somebody asks me about these two lines, they just intersect, right? They just are crossing each other. They're not parallel nor they're perpendicular, so we say they're neither. Going on to the next example. So again, we have some 4 points. I'm going to plot those. So think of steps, right? Get your coordinates, plot the coordinates, draw the lines. And this already can kind of lead you into what you think. Right now, in geometry, we've got to prove these things with the math. Just because I can see them or it looks like it doesn't mean they are. That's why we use the math to prove what we say. Okay, so the slope for CD we're going to find is 2. So let's find if EF is also 2, and that is exactly what we find. So the lines have the same slope, meaning that they are parallel. Okay, now in your notes packet, you have 3 remaining examples that are what I would call check it out examples. I'm going to ask you to go ahead and pause, do your calculation for those 3 examples, answer the questions the best of your ability, and then when you come into class, go ahead and bring it up and ask me what the answers to those are, and let's find out. Good work today.